For exercises 1 through 3, the perpendicular bisectors of ABC intersect at the point G, or the angle bisectors of the triangle XYZ intersect at point P. Find the indicated measure. Okay, so what they're saying is these are centers, and we have to kind of understand what the centers mean. So G, like this one here, what kind of center is this?
Circumcenter. No. Centroid.
Well, that's what we get. So that's the challenge, right? So we got to figure out what the distance from B to G is. Okay, and that one is not. It's not incredibly difficult, but it's not particularly easy. And we have the information that we need, but we have to identify it. So this is triangle ABC, and it says the perpendicular bisectors of ABC. So these are perpendicular bisectors. Now the perpendicular bisector is the circumcenter, right?
Sure.
Okay, so then what we need to do is we need to figure out the circumcenter. What's the property of the circumcenter that's going to be the most helpful? Does anybody remember? What does the circumcenter give us? So the circumcenter is equidistant from the vertices. So what that means is if I take a compass, and you don't have to sketch this out, well, I mean, you could sketch it out. But if I take a compass and I put it on the circumcenter and I draw it around, well, I didn't get it perfect, but it's equidistant from the vertices, okay? So what that means is that BG is the distance from the circumcenter to B. That's congruent to CG, because this is a vertex on the triangle, and it's equidistant from that. So then BG, which is congruent to CG, but what's the length of CG? 9. So that's why it's important that you can identify quickly. Some of you guys said it, perpendicular bisector, but that was given to us in the directions. And somebody said incenter, and that would be a good guess. And the way that you could test that, I knew it wasn't an incenter because this is really short. So if I were to draw a circle from there to there, it would just come around like this. But they also tell us, remember that the perpendicular bisectors, that's a circumcenter. So where those converge, that's the circumcenter. And then the incenter is the angle bisectors, right? So this one's going to be an angle bisector, which is the incenter, okay? So now we have the same property here. Now this is an obtuse triangle. So if I take, if I go from the circumcenter and I draw my circle, it goes through all 3 of the vertices. So that means, so let's label this. This is circumcenter. G is circumcenter, which is equidistant from the vertices. This is also a circumcenter. The circumcenter is outside of the triangle if it is an obtuse triangle. And here they're asked to find out what CG is. So we want to know what CG is, but we also know that CG is equal to BG, right? Because the distance from G to B is the same as the distance from C to G. BG is equal to what? 10. See how we did that? Now this one is an incenter because it's the angle bisectors. In other words, this angle is congruent to this angle is congruent to this angle, and this angle is congruent to this angle. And then another clue for the incenter, in other words, P is the incenter. Okay? Another clue for the incenter is that the radius of the circle is a perpendicular bisector of the side of the triangle. Not bisector. It's a perpendicular intersection. In other words, it's tangent to the sides of the triangle. So now if I take this, because P is an incenter, if I take my compass, and this is going to be hard because it's a small circle, it should draw a circle Okay, let me finish drawing my awesome circle. So I have this circle. So what that means is because it's the incenter, that just means that TP is congruent to UP is congruent to PS. And so since they're asking us what PS is, we know that UP is equal to 2. So that's equal to UP, which is equal to 2. Okay, what's your question?
How is the other one a triangle? I thought triangles only had 3 sides.
The shady part is triangle.
Yeah, the shaded part's the triangle. That's a good question. This one, the shaded part's the triangle. These lines are all the perpendicular bisectors, and they converge outside of the triangle because it's an obtuse triangle. It's a good question. We are going to skip questions 4 and 5 for time's sake. Basically, that you would draw a triangle on a grid and then construct the circumcenter. We're not going to do that for time's sake, okay? If you take the SAT, they'll give you a problem like this, but they'll already have the triangle constructed on the grid. And so if you do your construction, you'll get the right answer anyways. So, all right, now looking at this, what are these two triangles? Just look at the pictures. Are they circumcenters or incenters? Incenters. And by the way, it says in the directions, the incenter. So what we know about the incenter is that if I take and I go from the incenter to the side of the triangle, I'm going to get this circle inside the triangle, right? So now what that means is that PJ is congruent to PK is congruent to PL. Because they're all radii of the same circle that's inside the triangle. And then they tell us that PJ and PL equal these algebraic expressions, correct? So what are we going to do with those algebraic expressions? How, though? I mean, what's the first step in solving them? If PJ is equal to PL, what do I do? So I'll say PJ is equal to PL, right? We know that. What I was looking for was somebody to say set them equal to each other. 4x minus 8 equals x plus 7. Subtract x from both sides. I get 3x minus 8 equals 7. I'm going to add 8 to both sides. 3x equals 15. Divide both sides by 3 and I get x equals 5. But they want to know what pk is, so that means I got to find one of these. So PL is actually 5 plus 7, which is what? 12. So PL is equal to PK, which is equal to 12. Okay? Let me double check that. I'm going to check the solutions. Because, I mean, it is possible that I make a mistake. Highly unlikely, though. But we'll double check it just to make sure. What one is that? 6? 12. Yep, 12 is right. Thank you for noticing that. So 12 is the correct answer. And guess what? Number 7 is just like number 6, but let's go through the motions. I know that this is an incenter, which means that it is going to draw a circle inside the triangle. That's where the term incenter comes from. There's more formal definitions, but I'm just going to stick to what you guys know. So what does that mean? That means that PL is equal to what? PM, which is equal to what? PN. So all three of those are the same. Again, they give us PN and PM, so PN is congruent to PM. So we're going to say 6x plus 2 is equal to 8x minus 14. I'm going to subtract 6x from both sides. And I get 2 is equal to 2x minus 14. I'm going to add 14 to both sides. And I get 16 is equal to 2x. Divide both sides by 2. And I get 8 equals x. Now PL is equal to PN. I don't know, which one's the easiest one to do? I'm going to do this one. 6 times 8 plus 2. What's 6 times 8? Plus 2? 50. So since all three of these equal the same, I'm just going to say that PL is equal to 50. Which is correct. I remember seeing that on the solutions. Okay? All right, we're making good time. Let's cross off the rest of these. We're not going to do those for today. I just want to focus on the figures.